So let's continue. We have here notes. No, whenever possible, designer should provide extra support for the weak direction of a column. No, dapat good. Otherwise, the member is inefficient. It has an excess of strength in one direction when the KXL and KYL are different. No, effective length. No, KYL will control unless the Rx over Ry is smaller than the KXL over KYL. No? Then when the two ratios are equal, so meaning the column has equal strength in both directions. For most of the W shapes in the column load tables, this ratio Rx over Ry ranges between 1.6 and 1.8, but it is as high as 3.11 for some of the shapes. But Kasagara is between this range na 1.6 and 1.8. So this is the note. No? Because this is the start mo man itong basihan no sa ato ang in the table. Have here another example that will support or that will to better understand this note. The column shown in figure 4.13 is subjected to a service dead load of 140 kilopounds and service live load of 420 kilopounds. Use A992 steel and select a W shape. Then, yes, from the figure, no, you have here the strong direction, support in the strong direction, meaning this whole length, no, of the compression member. Then we have this support in the weak direction. Kung imong tan-awon, we have gi-supportahan siya in the weak direction 6 feet, no, 6 feet. Then we have another 8 feet and 6 feet. If you try to understand this one, the critical, no, buckling is the 8 feet, not the 6 feet, because this is greater than this. So meaning this will govern in your KX. KY. No. So we have this in the strong direction, KXL is equal to 20 feet since it is pin supported now, both support both ends. So meaning your value of K is 1.0. So manang KXL is equal to 20 feet and the maximum KYL now from here is 8 feet. The effective length KXL will control whenever this KXL over RX over R is greater than the KYL, or this RX over RY is less than this KXL over KYL. So in this example, we have the value of KXL equal to 20 and KYL 8. So the ratio, the answer now 20 divided by 8 is 2.5. So if this KXL, KXL will control if and only if the RX over RY is less than 2.5, no? So the KXL will control if the RX over RY is less than 2.5. Diba? Since this is true for almost every shape in the column load tables, the KXL probably controls in this example. Say, kanang kung ang RX over RY is less than 2.5 gani, less than this one, meaning the KXL now in the strong direction controls. But remember, we have the ranges now of the ratio Rx over Ry. So we assume nga since kung less than ang kini, less than the Rx over Ry, less than this 2.5, meaning this Rx, this Kx in the strong direction controls, no? Between kasagara is between 1.6 and 1.8 man. So we assume nga 1.7. So probably kaning KXL controls in this example, no? Not the weak axis but this strong axis. So manang we assume nga the Rx over Ry is 1.7, no? So atong gi-assume ha dayon the KXL over Rx over Ry. Now KXL is 20 divided by this assumed ratio of Rx over Ry 1.7. The answer is 11.76, which is greater than KYL, no? So meaning pasabot is this KXL, this control, no, in the strong direction controls. Then we solve for the factored load. For LRFD solution is 1.2 dead load plus 1.6 live load. So this is from the problem, no? The dead load is 140 kilopounds and live load is 420. Since kani siyang 11.76, in the column load tables, wala man gini siya nga exact amount, exact value. So we kuan ni siya ato siyang i-round off into 12, no? Instead ng 11.76, enter the column load tables with KL is equal to 12 feet. And there are no WH shapes with enough load capacity. So kaning W.76 ato siyang himuon nga 12. Then kung tan-aw nimo siya sa table, wala siya W8. Balik ta sa W8. This one, no? 12 nga greater than, dapat greater than 840 kilopounds, no? Slightly greater than. Kung 12, kung tan-aw nimo W, kuan, wala siya. Wala for W8. No? Oh, wala. So, ato ta sa W10. Remember, the value of your KL is 12. Is 12, then pila tong PU? Your PU is 840. So, kung tan-aw nimo diri, 12. Wala siya diri. So, dito ta sa ibabaw. W10, 12, 800. Isa ka ni. W10 by 88. Dali wala pa. 841. So, W10 by 88 with strength 940 kilo. Yes, we try the W10 by 88 with design strength 940 kilopounds. So, kining W10 by 88, again, tanaw na po mo ang iyahang radius of gyration along X and along Y, then get the ratio. Nakato na pong table. Remember, sa to, W10 by 88. Tanaw ni mo sa table, W10 by 88. W10 by 88, this value. W10 by 88, value of the radius of gyration along X is 4.54 and along Y is 2.63. So, ang ratio ana is 1.726, no? 1.73. This one. 1.73. The actual KXL. No? This is in the strong axis now. 20 divided by this ratio, the answer is 11.56, less than 12 feet. Okay, this is the actual, di ba? Then, by interpolation, dapat siya mo greater than 840 kilopounds. So, by interpolation, again, tanaw na to ni siya nga value. I mean, atong siyang i-compute nga value by interpolation since wala man siya exact nga value sa table, di ba? Kung tanaw tayo, written by 88. That is between 11 and between 12. Value is 11.56. We have 11, 11.56, 12. The value for the written by 88 is 973.40. So by interpolation, what is the exact value for 11.56? No? So, so the answer is, by interpolation, the design strength now is 955, which is greater than 840. So this is okay. This W10 by 88 is okay ni siya. Again, we check the next shape. Napamatay W12 and W14. No? For W12, we check the parehara mag procedure. Una is we'll check the assume no column load 2.5. So again, we'll assume nga ang KL nimo is 12 feet. So kung tan-aw nimo sa W12 na pudta, then 12 800. So wala siya ni pasar diri. Dito ta sa ibabaw. At 12 then greater than 840. So we have this W12 by 79, no? Basta kay the value for 12 is this 887 greater than 840, di ba? So W12 by unsa ta siya W12 by 79. So W12 by 79, tan-aw na pud nimo ang W12 by 79 sa katong isa ka table to get for the value of your radius of gyration along x and along y, di ba? W12 by 79, this one. So wala kay radius diri siya sa ibabaw. W12 by 79, the radius of gyration is along x is 534, this is 79, and along y is 3.05. So kuan nimo ang ratio ana niya, the answer is this one. The answer is 1.75. Then compute no the actual value of your KXL or the effective length along the strong axis. The answer is 11.43. Again, by interpolation, you will get no interpolate kasi since wala man kay value, exact value for 11.53. The value no that you will get through interpolation is 900 kilopounds, which is again greater than 840 kilopounds. So again, this is okay. This shape is okay. W12 by 79. So next is we'll investigate the W14 shape, the last shape na in the table. Then kung tanaw nimo sa W14 na for KL is equal to 9 feet. Investigate W14 shape for Rx where Ry is equal to 2.44. The approximate ratio for all likely possibilities. Again, we assume this 12 feet, no, KL. So, kung atong tanawon ang W14, no, next shape, for KL is equal to 12 feet, then, dapat mo greater than siya sa 840. 74. Greater than siya sa 840.